yesterday we started to learn about how do we tell people about the chemical change that is happening. One of the ways that we describe a chemical change is to use a word equation. For example, this is probably one of the most important chemical reactions I could teach you about in all of high school science. This is the reaction of photosynthesis, and this is why life on Earth can exist. When autotrophs, such as plants, taking carbon dioxide and water, they can use the light energy to produce oxygen, which is what we breathe, and glucose. This is a sugar. For example, if you have a piece of fruit and you taste that sweetness, it is because the plant has stored glucose and another sugar called fructose in the fruit that you are eating. What is the difference between what's indicated by A and what's indicated by B? Okay, so this is what you start with. There's a fancy word for that. It's called reactants. Reactants are always found on the left side of the equation. Reactants are what is used. Some of you are doing commercial cooking in period 1. Okay. All right, so you're going to be making me some tasty things? Oh, okay, excellent answer. The ingredients that you use, for example, if you're making potato salad, you have your potatoes, you have your dill, you have radishes, maybe some celery. All of those ingredients are reactants. When you put them all together,
makes a solution.
You make something, right? And what you've made is different than what you start with. I don't think many people dip raw eggs in mayonnaise and then eat them. No, but when we cook the eggs, dice them up, add mayonnaise and potatoes, oh, it tastes really good. So this side is what is made. And the fancy word for that?
Solution.
Products. In social studies, have you studied about producers? Okay. I can't remember which social studies it is in, but you study producers that, for example, factories that make stuff that we can use. On both the reactant and the product side, there are these plus signs. Why?
They're like saying that, like, and the other things, like they're adding.
So that's telling us that there's more than a one thing. So we have light, and we have carbon dioxide, and we have water. And we need to combine all of those things together to make oxygen and glucose. We wouldn't say light, carbon dioxide, water, oxygen, glucose. That makes absolutely no sense. We have to distinguish carbon dioxide as being a separate entity, a separate substance than carbon dioxide. What does this arrow tell you? Okay, so this tells us that something's happening. The magic of chemistry is happening and we're getting something new. So this is indicating that a change is happening. In reality, there should be many arrows here, because this is not one step. This is a series of many, many steps. We don't study that thoroughly until you are in Biology 30. If you choose to do Biology 30, it's not a mandatory credit. Does that help you with your answers to the second side of that worksheet?
Yeah.
Any questions so far? Okay. What we are going to practice first today is going from a sentence description to writing that word equation. So you don't have to copy this down, okay? I will let you know when to copy things down. You're going to get a sentence like this. It's going to tell you about something combining with something else to make something new. And you need to figure out what is being used and what is being made.
Magnesium and hydrochloric acid are mixing to make hydrogen gas and water.
And so what I often ask people to do is say, okay, why don't you highlight in 2 different colors the things that you start with and the things that are made. So that makes it a little bit more obvious about what you're working with. Then you can actually start building. Now honestly, it does not matter if you put hydrochloric acid first, then went plus magnesium. What matters is that both of them are reactants and they're on the left-hand side of the chemical equation. Then we need to show a change and our 2 substances on the right-hand side. So this is what you're going to be doing today. Normally, we don't do this one slide at a time. Otherwise, it would take far too much work. All right, you've done this one already. See if you can put this together. I've underlined things that go together because you're not very familiar with how things are named at this point. So, for example, calcium hydroxide is one substance. Water is another substance. Calcium hydroxide solution is a 3rd substance. See if you can build the word equation, please. You might find it helpful to use highlighters to help you identify reactants and products, just to make it stand out a little bit, especially at the beginning when a lot of these compound formulas, or compound names, don't really mean a whole lot to you yet. Once we come back from the break, we'll learn how to come up with these names and their symbols. So that is the correct answer. You could have written water plus calcium hydroxide. It doesn't matter which comes first and which comes second. What matters is that they're both on the left side or the reactant side. Only one thing on the right-hand side this time. Sometimes you will have chemical equations that will only have one thing on the beginning side or the reactant side. It just depends on what's going on. How are you with this? Do you think you can tackle something a little bit more challenging?
Yeah.
Probably. Okay. In this worksheet, you have several reactions which occur in real life. So read the following statements. For each reaction that is described, please identify the reactants and the products. So you can do that by highlighting, for example, and then write a word equation to represent the reaction takes place. It gives you a hint. Remember that when burning takes place, oxygen is one of the reactants. You need that for question number 1. In question number 1, octane is a component of gasoline. It burns in an automobile engine. Carbon dioxide and water are formed. Please identify the reactants and the products, then write the equation. Correct answer for number 1 is octane plus oxygen, arrow, carbon dioxide plus water. Have you heard about something called acid rain?
Yeah.
Okay. This is a problem in the Ontario, Quebec areas where there's a lot of steel factories that produce something called sulfur dioxide. Acid rain is formed when sulfur dioxide reacts with the water in the air to form sulfurous acid.
For the first one here, we got octane here. Oxygen, where'd you get the oxygen from?
This gives you a hint here. The second statement again, acid rain is formed when sulfur dioxide reacts with water in the air to form sulfurous acid. The correct equation for this is sulfur dioxide plus water, arrow sulfurous acid.
Yes.
Try the next 3. The third reaction results in the formation of smog. If you have ever been to a major city, have you ever noticed that brown layer of haze over top of the city? That's nitrogen monoxide. So this happens inside of the automobile engine where nitrogen from the air combines with oxygen, and because of the high heat of the engine, it forms nitrogen monoxide. Rust is very undesirable, but unfortunately a fact of life for us, especially since we salt our roads so much in the wintertime. Any bare iron, so for example, if the paint in your car is chipping away and it exposes the metal underneath, can react with oxygen and water in the air to make rust, which has the big fancy long name, iron 3 oxide trihydride. Yes. Hydrochloric acid will react with zinc to make hydrogen gas and a salt known as zinc chloride. Eventually, where we're going to move to after break is instead of writing word equations, you're going to use the periodic table to come up with symbols. For example, eventually, this will be
H2O, that's all I know.
Hydrogen is
that.
Oh, I can remember SO2 and SO3. H2O.
You don't have to because you get tables.
Oh, we get to use them?
So if you take a look at that yellow booklet that you got on the first day of class, I believe it's page 3 that has all of your ions on it. There you go. So SO3 is on page 3 here.
Solve button.
Okay, how are you feeling about this? Part of the challenge with this is you're not familiar with namings of molecules yet. So a lot of these names don't mean a whole lot, and it's hard to tell if something goes together with something else. Okay. On the back is an assignment that we're not going to do until Thursday. So here's what we're going to do with it. We're only going to do the first 5. We're going to do word equations. Here's what I want you to do. This is really important. Okay. So what I want you to do is write out the word equation. And then I want you to leave about 4 lines of space. So for example, if this is your line piece of paper, 1, 2, 3, 4, and then do question number 2. Okay. Because we're going to have to do something with these word equations, and I haven't taught you that yet. But some of you might figure out where this is going. So just write out your word equation, then leave about 4 lines of space, write out the second equation. Question numbers 1 to 5. What we're going to work on over the next couple of days is taking your skill of making a word equation that you learned today, and we are going to be using those word equations to solve for a missing mass of substance. And we can do this because of this law of conservation of mass, which says matter cannot be created nor destroyed. So if you start off with copper and sulfur have to be made. They might be with different partners. They might be in different states. But what you start with, in terms of number of particles, has to be what you finish with at the end. You can't, if you have missing mass, something has leaked or evaporated or something. Tomorrow, we are going to do a lab that will take us a class and a bit to do. Okay, so please make sure that when you come to class tomorrow, you have foot gear that is appropriate for the lab, so no flip-flops. And ladies, bring something to tie your hair back with, please.